Oh boy. All right. Is this recording? It is. Okay. I clicked the button. It's recording. Awesome. It never happens the first time. Okay. Oops. All right. So, how do I turn this? If anyone hears an echo, just please tell me. I don't know. I really don't know how to mute this. It's weird. Anyway, if it's not that big of a deal, we'll just keep moving. So if we have code like for what we had person, like we had a person who has, a name and a birthday, and it's outside the box. And then let's say we had, we wanted to use that code, but you don't want to constantly write the same code over and over again. You can inherit that code. So I want to have a class called Spice Girl. Also, I'm sorry, my handwriting is terrible. Spice Girl, and then Spice Girls are, they're going to have like their spice, and well, that's it. They're just going to have spices. And then we have a class called, where we left off last week, Beastie Boy. And I think I forget exactly what the exact attribute we gave them, but we said they had I think it was respect, and that was some Boolean, and the rest of these are all strings. And clearly, I did not draw these big enough. So when I create a new, a new person, or a new Beastie Boy or Spice Girl, I would say, like, not const. I would say, Spice Girl S equals new. Oh no, I'm just gonna go in here, Spice Girl. And what happens is I could then say, S dot spice, which is referring to this thing right here. I could also say S dot name, referring to that, and S dot birthday. Whoop. Oh, dang, hit the bottom of the screen. It's referring to this guy. So that's, ultimately speaking, the biggest takeaway of inheritance, that thing. So let's now move to actually like writing code and looking at it. How do I get out of this now? Yes, stop the other one. Desktop one. Okay, so this is gonna drive me nuts. I'm gonna just leave the call. There we go. All right. So we've got from last week. Oh, get out of here. We had all these Beastie Boys and Spice Girls things. We're not gonna dig too much back into that because we want to, move forward, try different things. It's like also Beastie Boys and Spice Girls are very fun. I think that they might not be the best moving forward. And by that I mean, let's just create a brand new project and do stuff with that. So I'm gonna right click my package explorer, call this, a really, really famous, I don't say famous, typical thing you're gonna see. So you're gonna see this a million times, today included, when people talk about inheritance, polymorphism, they always talk about, don't create a module info Java, don't do it, it's bad news. So I say new, let's say new package. This is new for us. We haven't created packages, but new class. What am I going to call my new class? Excuse me. Main class, just main, capital M main. And we've got this. You notice I could have clicked the instantiate with the static main void, but I didn't, so we're gonna have to write that out ourselves. But got package, main package. All that really means is that we've got essentially a folder called main package where all of this lives, all this code lives. It's pretty fun stuff. Everyone loves folders. So because we forgot, I forgot to click that, get that mainstream button. I'm gonna say public static void main string array called args is gonna come in. There we go. System out. And to double check, print line, we're in main. Always good to just run it. We're in main. Cool. Other than package, or other than seeing this package right there, like that's all this is just basic boilerplate. So last week we talked about not only inheritance, but, and we are actually going to open this up, we talked about sort of encapsulation of data. So having private methods, private variables, things like that. So ultimately what that means is, so as we see, private string name, private string birthday, we can't actually ever say, regardless of whether we make a person or a Beast Boy or Spice Girl who inherit from person, we could never say so-and-so dot name because this is private. We could, however, say so-and-so dot print deets and then print the details from there. Or if we wanted to, we could also have written, a getter called, well, typically you could write a getter, name it literally anything you want, but 99 times out of 100, people always write getters as the names of their variables. So I could say, public string get name, and then spell return correctly, then we could say return name. And that would be our basic getter. Otherwise, without that, there's no way we can access that variable whatsoever at all, which is a little potentially, well, it's good oftentimes, because typically speaking, if you're going to write code for other people to use, you only want them to use the functions that you yourself are like, they're safe. You don't want someone to come in and start messing with stuff behind the scenes. That being said, as you're writing your own projects and doing like you're only interacting with code that you yourself will ever be interacting with, using private, like it's up to you how you want to do it. It is a good habit to form though. So let's go back to this guy over here. So today we are going to talk about, well, vehicles. Ooh, I can't say, I don't know if you'll actually run into this if you ever do take a programming course, but this is, I had like 3 courses. This was always like the main example. Yep, yes.
Someone asked, could you go back?
Oh no, yes, I can go back to what am I? I didn't have the chat pulled up. Thank you so much. Okay. Can I go back? Go back to a person? Or you know what? Let's start from scratch, entirely from scratch. So we'll go over last week. So we started with, you know what? We'll start from scratch, literally from scratch into this week. Why not? But we're gonna add one more step. We're gonna say source new package. Let's say people, just people. That'll be fine. Finish And I did not create a package.info. That's it. So people, new class, person, then that's it. Empty class person, that's all. So we've got, let's actually, you know what? Let me annotate this. Now I wish I didn't log out with my second place. Okay. So we've got, how do we, there, draw. Okay, so, oh, nice. So we've got 3 classes in this example. Nice. Oh, this is working out great. Didn't know I could actually do this. So we're going to have person, Spice Girl, and Beastie Boy. And then here's the lines that connect them. So they will, both Spice Girl and Beastie Boy will inherit from person, right? And like also this is just some intense stuff. It took me half a semester to get to like fully grasp this. And it's just, it takes time and effort, and the more you do it, the more you'll get used to it. So hence the exercise today. Very exciting. So got person, and every person we're gonna wanna have a name and a birthday. That's it. Then we're going to, well, first let's just we'll make sure that everything's public. There. Then we got name and birthday. Then I'm going to say public person as our constructor, because we want anyone to be able to create a person. Then let's say, you know, name equals no name, or yeah, no name's fine. I don't need to make jokes. Birthday equals 1/1/2020. There we go. That's our default person. They're very young and they don't have a name yet. And then it's just we could write our own getters and setters, and it's always it's good practice to do it, but you can always right click. Like let's say we have name, you can always right click name and go to refactor right here, scroll all the way down to refactor. Then should be a add getters and setters. Where the heck did you go? Oh no, where are you? Well, crud, it's in here somewhere, but also that's not the point of today's lesson. So could add getters and setters with the right click. It's somewhere in that list. So let's just write a quick getter and setter, public get name. Whoops, we just return type, public string. String is our return type. Get name. We're not going to call anything. We're not going to send any parameters in with get name. And then we want to return name. And then public string get birthday, return birthday. And then finally, you can change your name. You can't change your birthday. So let's have a setter for name, and then we're going to say public void, because we're not actually returning anything. We just want to set something. So public void set name. We're going to take in a string with, call it new name. Then say name equals new name. And if you remember from last week, you could also have called this name. However, because of scoping, the compiler or the Java runtime thinks that these are all, we're referring to the same exact thing, and we are, because they're all pointing, they're all, I mean, if you want to look at it, they're all the same color. They're all brown. This name up here is blue. The colors are very helpful. So we can write this dot name to refer to the blue one at the class level, at the whole class level. However, that the keyword this can be very confusing, right? So let's just say new name for now. New name. There we go. And notice that this dot name can always be used. It's totally fine. So, got it. New name equals new name. We did it. So now, also for the sake of time and people, I'm going to create another class called Spice Girl. And Spice Girls, oops, just going to have Spice public Spice Girl. Then I'm going to say Spice, the default Spice is always Scary. Scary Spice was the coolest. So, and let's make this public as well. Cool. So, we've got, just pretend we're also doing all of this for Beastie Boys, but that's going to take too much time. So, what we have is we have person with name, birthday, then Spice Girl with Spice. So when we create a Spice Girl in our, in our main package, when we want to create a Spice Girl, check this out. So we say Spice Girl, Scary Spice equals new Spice Girl. Oh man, check this out. So last week when we did this, this worked completely fine. This week, because we did something slightly different, the packages, we're reading errors. So if I hover over this, it says Spice Girl cannot be resolved to a type. Any thoughts about that? How, so they're in the same general project structure. Maybe import people.person, people.spicegirl. Whoa, check it out. Blam. This is how you start setting up things with packages. You can set up like really large file structures. So you can actually start importing stuff and not have, you know, things get too cluttered in one workspace. So highly recommend, if there's anything you take away from today, one, well, review of inheritance, but two is using packages to kind of keep your projects somewhat clean and keep your files small. Just trust me, they get big. I remember I one time had a project in school and it was like 2,000 lines long. And if there was a bug, oof, it took hours to deal with. It was rough times. I did not take the lessons of my teachers. So now, anyway, let's go back. Spice Girl, with Scary Spice, new Spice Girl. So we're calling this, like control click into here, Spice Girl, we're calling that. And right now, if I try to access anything, I say, you know, Scary Spice dot, and see Spice, right there, we made it public, and see it. But interestingly, if I just Scary Spice dot, I try to say dot name, it doesn't Doesn't work. There's no actual name attribute in Spice Girl. You'd think because we wanted to inherit that we'd have access to it, but in order to inherit, I already clicked up here, so you probably remember from last week that we did something special at this level. It's not just, other than drawing a thing, you actually have to say Spice Girl extends person. And what that does, that takes all of these attributes and kind of lets us access them from down here, so long as they're public and or not private, and also not, yeah. So now let's say scary spice dot, you get birthday, name, and spice. Awesome. What if, however, we removed these public identifiers, or identifiers, the public, words. If I come down here and say scary spice dot, and this is, so last week we talked about, on top of, inheritance, we talked about, things being protected or private and public. And then we mentioned that by default, these are protected, or if you leave it blank, it's still protected. And what did that mean? I mentioned we'd get to it later. Today is later. This is protected. That anything within this here package can access person.name, person.birthday. So in Spice Girl, I can say name is Mel B, birthday is, I forget her birthday, something. But in main, if we're trying to access that same data, Scary Spice, we can't, because it is name and birthday are, oops, did not mean to switch those lines around. Both of these are protected. So any protected attributes that exist in here, come on, draw. In this package are blocked from being accessed in this package. There's a big gate there. It's like you can only see public stuff. That's it. So goals are either to then make using getters and setters your option. So I could do scary spice dot set name and then pass in Victoria. Not actually name, but maybe Posh Spice wanted to be scary. Who knows? So we have scary spice dot set name because that's public. So now we can still access our data, but now we're being proper about it using our public setters instead of just trying to say scary spice dot name, because again, that is protected because we're in a different package, which is very cool. So that was last week from scratch with a little bit extra on top with packages. This week, we're going to do that plus some. So let's create one. Let me clear the screen here. Well, shoot, are there any questions on last week's review? This week, we will still do the same, thing with talking about like starting from scratch, building a class, and we're going to do it in packages because knowing how to use packages is helpful. We're going to build a class, that inherits from another class. Then we're going to talk about polymorphism. Before we move on any further and get kind of in the weeds, any questions? Oop. Just a little fast? Well, we will slow down. I'll say, please just type, it's too fast all the time.
Hey, Matt. Also, I think if you right click and go to source, I think that's where you can generate the getters and setters.
Is that what, dang it.
That might be it.
Look at that. Yep, thank you. It's not, I think it's in refactor and IntelliJ. Okay, thank you so much. So earlier, we were talking about getters and setters. So there's getters, just ignore the hash code, all these extra ones, but if you say generate getters and setters, well, the only one we have left to generate is birthday, and then we click generate, and blam. We now got our own very set birthday. The generating of getters and setters is cool, and a lot of the generating of a lot of these files is, for a lot of these methods, is really neat, but sometimes the code will look a little different, say, than how you would have written it. So like this used birthday and did this dot birthday equals birthday. It'll work just fine, but it can still be a little confusing. I used to try to avoid auto-generated methods. I think it's good to just type stuff out, but if you're ever in a hurry, say for a robotics competition, do they make you code that the day of? Probably not. That would be crazy. That would be so insane. Anyway, let's create a brand new project and say new Java project. Name it whatever you want. I'm going to name this Polymorphism, which is a ridiculous name, but you'll hopefully see, well, not see. It's a crazy name for something that's not that crazy. So I'm going to create a new package. In the new package, I'm going to just call it main package, just because. Then right-click main package and then do class main class. This is where I want to put all of my code that'll do all the work. And then click this guy public static void main so that I don't have to type it. Look at that. Beautiful main package, main class, main function. I should maybe have considered being more clever with names, but main is a nice place to put stuff. So now, before we were talking about having our main package, we had a people package. We can now, let's create a different package this time. We're going to right-click source, the new package again. Then new package, say vehicles, because this is always a good example of, well, of inheritance. So then we right-click vehicles. Let's, you know what, before we even go any further, let's take a step back, because when you start coding stuff out, you're always, especially in like an object-oriented way, you're gonna like immediately start coding. I don't want you to get the idea that like you just know how this is all going to go. You want to think of a model essentially of how this is going to go. So what is, before you start writing a single line of code, you want to know like, okay, I want to have some object-oriented approach to like vehicles. So what kind of vehicles are there? There are You know, we think of cars. What else? There's trucks. What do both cars and trucks have? They have wheels. So right now, ooh, crud. Let's go down here. We have car, a truck. What else? I don't know. Bike. What other kind of vehicles are there? There's a plane. You know, let's keep those 3 for now. 4. Geez, I can't count. So up here, say car, truck, plane, and bicycle. Bicycle. That's how you spell bicycle. Oh man, don't spell bicycle very often. So what do each of these have? Well, a car has 4 wheels. I'm just gonna type it back here so I can just easily delete it. So a car has 4 wheels, engine, you know, what else? Air conditioning, radio, sure. Truck, also 4 wheels, also engine. The trucks have air conditioning? Probably. We can just assume that most trucks have air conditioning. Trucks have a radio, heck yeah, they do. They also have, you know, a bed, well, oftentimes they have a bed, assuming this is a pickup truck. We're gonna just assume that because we don't have enough time to actually conceive of all of these things. It's just too much to model out. Real life is not always code, not always. It's oftentimes more complex, and you have to sort of just write your code to fit the best possible model. So we have a car, a truck, a plane. Planes, not always, but we're just going to say planes, they typically have 3 wheels, 2 in back, 1 up front. They have an engine. They have a jet engine, not the same kind of engine as a car. In fact, these are internal combustion engines, but we'll say just gas engines, because jet engines also they combust as well, but you know. And then the planes have air conditioning, yeah, sure. Yeah, of course they do. Conditioning. Planes have radios. They also have radar. Planes don't really have beds. They have cargo holds. And that's enough for plane. That's a lot. Then finally, we have bicycle. So bicycles have 2 wheels. They have no engine at all. Their engine is us. So say pedaled. I don't know how to say oh my gosh, this is embarrassing. I assume it's P, whatever, couldn't tell you. Is there air conditioning? There's no air conditioning at all. There's no radio. There's no radar. There's no cargo hold. There's no bed. That's it. It is just 2 wheels and some pedals. So what makes all 4 of these vehicles? Is it their wheels? Is it their powered? Well, let's create a class because we want to start to abstract these things. A bike a vehicle? What makes a plane a vehicle? Well, ooh, where's the drawy thing? There it is. Let's say vehicle. So vehicles, all 4 of these have wheels. So we could say in our code, we're going to write wheel count, and then we're going to put an int after it so that we can say, okay, we know we want that to be some integer, 2, 3, or 4, maybe 18. There are 18 wheelers out there. So got that, wheel count. now, what's next? So we've got gas engine, jet engine, and pedal. I guess you could say, engine type if you wanted to. Say string, say engine type. I'm going to say engine type because pedal's not exactly an engine per se, but it is how, everything's being powered. It's by mechanical physical exertion as opposed to combustion. So we'll do that. And then air conditioning, radio, bed, radar cargo holds. Those don't really pertain, except for to these three: cars, trucks, and planes. I also made vehicle way too big. So for now, say wheel count, engine type. There we go. We know we've already got, ooh, look at that. A cool arrow. We've already got that for bicycle. So bicycle can inherit from vehicle, and then we're great. We can say 2 wheels, and then engine type, we can say pedals or mechanical or what have you. However, do we really want to, for car, truck, and plane, write down air conditioning and radio for car, air conditioning, radio, bed for truck, and air conditioning, radio, radar, cargo hold for plane? You can always do that, but the main point of all of this is to say, like, heck no, why repeat code when you don't have to? So how do we do that? Well, you can inherit once, and you can inherit from other things that inherit. So you can create a giant chain of inheritance as much as you want. Wouldn't recommend it because oftentimes you'll get, well, caught in the weeds, just like you're inheriting too many things. But it is good to like have chains of like 3 things to sort of abstract as much as you can without making your code too difficult to read. So what do we want to call this? Where's the text one? We can call this guy, combustion powered thing. That's really hard to read. So there. All right, cool. So we got our combustion powered thing, and we're going to say, cool, this is combustion powered. Well, guess what? All of our combustion powered, vehicles all had air conditioning. So, and then they all had radios. Is it radio type? Why not? And then I guess I should have written air conditioning type, but there. That didn't work out very well. And then finally, there's not really much else we can do here. Can't easily abstract bed because only the truck has a bed, and then we can't abstract, radar or cargo hold because only the plane has radar or cargo hold. So ultimately speaking, now we can start to think of like the rest of our lowest levels. We can say truck. The truck has a bed. Plane has a cargo hold, and also shoot, radar. Forgot about that. So now if we start drawing, these relationships to each other, so the car is going to inherit from combustion powered thing. The truck is going to inherit from combustion powered thing. And the plane is going to inherit from combustion powered thing. Great. Also, we want them to have wheels and engine types. So, and then typically speaking, this would all be one giant tree, but because, screen size is not that big, we're just going to draw a really long arrow so that both bicycle and combustion powered thing inherit from vehicle. So what this looks like is, here's vehicle. We're gonna say this over here, B for bike, CPT for combustion powered thing. And then I'm just gonna do this 3, 4, we've got plane, car, and truck. This is not the prettiest thing, but ultimately speaking, this is sort of the tree of how all of this flows. So let's, oh boy, actually, shoot, I'm just gonna clear all of it. There we go. So let's do this. And we don't want to delete that just yet because we want to come back to it. So inside of vehicles, we're going to create one, our class called vehicle, capital V, vehicle. Vehicle, there we go. Sometimes spelling is hard. So we're in the package vehicles, we have our class vehicle. Then we'll say, what did vehicle have? A wheel count, and just an engine type. Or we could really just say type of power source. We'll say power source. I think power source sounds way better than engine type. No one calls their legs their walking engine. It's not a thing. Should be though. That's a cool name. Cool name. Okay, so we've got wheel count and power source. Awesome. Now, excuse me, we've got, I'm going to create another class. I'm going to say bicycle. And I want bicycle to extend vehicle. So now our bicycle is going to get everything from vehicle. And by everything, we mean wheel count and power source. And then we are going to create our other class called combustion powered thing, which I'm sure there's a better word for that, but it's more fun. We want to say extends vehicle. So now, so far we've got the vehicle, got the bicycle, combustion powered thing, and that's where we're at. So extends vehicle. Did I misspell? Yes. That, I don't know how that would be pronounced. Okay, so now we've got combustion powered thing, extends vehicle. Then what we want in here is, we want, I already forget, we want an engine type, or no, radio, it was the name, that's what it was. Air conditioning and radio. So, string, int, what are radio channels? They're doubles. Radio channel, can't really tune to the radio on a bike. Or there's no built-in radios, I suppose. And then say string, why not? Let's make it int AC temperature. Let's say AC temp. 1 through 10, typically speaking, in a lot of cars. or at least they were in my older cars. I guess now my car has a actual Fahrenheit degree. There, in Fahrenheit. And then finally, got this guy extending vehicles. Now we want to extend combustion powered thing with car, truck, and airplane. Awesome. So in airplane, well, we didn't even talk about this, but of course airplanes have wings. We're gonna say wing type. Then we also had radar. Let me just say, radar degrees, radar type, whatever. We're just gonna say string radar. Yes.
Cargo.
And then, let's say what?
Cargo hold. That was the other one.
Cargo hold. Thank you. And then let's make this an int. Say cargo hold capacity in pounds, because planes can't, their cargo holds are too heavy. They don't fly off the ground, and then they just run off the runway. My brother's a pilot and has told me horror stories of that happening, which I shouldn't say. That's terrifying. It doesn't happen that often. Okay, so we did airplane. Let's do car. Cars have, well, I just realized we didn't do it with airplane. Extends combustion powered thing. Also, we said combustion powered thing. A cool trick, if you're in Eclipse, I know combustion starts with COM, but I can't remember how to spell the rest of it. I can just press control space, and then it'll try to auto-complete the text and be like, hey, did you mean this thing? And then combustion powered thing is at the very top. Hit enter. Heck yes, I did. That's what I meant. And it does the typing for me, just kind of nice. So, ooh, it's 5:23. Oh my gosh. Okay, so we've got wing type, radar, cargo hold capacity, and then by extending combustion powered thing, we get all the stuff that we defined up here and all the stuff that we defined in vehicle. Now for car, there's not really much else that we really care about. So it's just say extends combustion, control space, combustion powered thing. I can just forget car for now. Then finally, truck. Truck has a bed. Then let's make it an int, bed capacity in gallons, in case you wanted to fill it up with, because liters also works, but gallons of sand, liters of sand, whatever. We could also do it by weight too, but whatever. So we've got our truck, our car, and our airplane. Let's do that real quick. Come on, draw. Car, truck, and our plane. This is why I didn't go to art school. So we've got these, and so these three, the car, truck, and plane, are inheriting from the combustion powered thing, which is inheriting from vehicle. Whereas bicycle, not combustion powered, we don't need it to be under this. So we're only inheriting from vehicle. That's it. And so this is one of those cool things of inheritance. Like if you would say like, if you ever like are writing out code and abstracting things, and you realize you're repeating stuff a bunch for like 3 out of 4 of them, you can just write a separate class and write the code only once and put all of it there, so you have a single source of truth, and from there everyone can inherit. So car, truck, and plane, instead of writing that code 3 times, you only write it once in combustion powered thing, and then you extend it in each. It's really nice. So what is the one thing we are forgetting? And by that, I mean, it's already 5:26, so shoot. Just gonna say this right. We're forgetting constructors. So car. I'll make this public. Oh, come on. Public car. Wheels for, wasn't wheel count. It's 4. Also, if we look inside of combustion powered thing, we also have radio channel and AC temp. Radio channel, no one listens to the radio anymore, but no, wait, 88.1, community-driven radio, pretty cool stuff. They're great. They've got a bunch of really goofy radio shows. Highly recommend if you ever find yourself listening to the radio. So 88.1, and then AC temp. Again, commands control space is your friend. AC temp equals, I like to keep my car pretty cold, say 62. I don't know why I keep my car cold. I'm always like freezing, but I like it. So we've got our car, and then honestly, for the sake of time, I'm just gonna do bicycle. So bicycle, wheel count is 2. And then also, we look inside a vehicle, there's also power source. We didn't actually do that for car. It's gas. Power source can't. Oh, weird. I must have mistyped it. Power source equals gas, and then for bicycle, power source. Oh, I wrote power source. Okay, that makes sense. Well, I eat a lot of burritos and pizza, so that's what powers me when I ride my bike. So there we go. We have this fantastic bit of a vehicle, or a bunch of different types of vehicles, but with relatively, like, these are tiny classes, but we're getting a lot out of it. My car has access to all of these things, and our bike has access to the vehicle too. So let's create, let's say, car. My car equals new car, and then call the constructor. What's happening? We got red, these red squiggly dudes. Say, okay, car can't be resolved to a type. 5 quick fixes. Quick fixes don't always help, but they kind of generally point to the right direction. So if I look at the very top when it says import car, and then parentheses vehicles, then it's like, you know what? That's exactly what I want, because I know I have lots of things in vehicles that I want to import. So import vehicles.car. So I have car, my car equals new car. Great. And then, well, like that. Honda Accord. Heck yeah. So cool. It's good. That's my car. Then bicycle. Surly equals new bicycle. So what's it complaining about? Naturally, we didn't import bicycle. So again, import bicycle. But there's still this red squiggly. Well, one, because I typed bicycle. it completely misspelled this, which is not the error we're supposed to be getting. There we go. This is the error we're supposed to be getting. All right, so you hover over it. Following along says the constructor bicycle is not visible. What happened? Well, what happened was, because we're doing things in different packages, you always need to make sure that when you have a constructor, if you want to access it outside of your package, then make it public. You might be wondering, like, what's the point of doing packages if you don't want people to access some of the code? And that's a great question, but think of it like this. We want a bicycle, we want a car. But you know what I don't want someone to do? I don't want someone to create a combustion powered thing. So, one, I can make this class just not a public class. And then two, I can just leave this as protected. So literally anyone inside of this vehicle's package can access combustion powered thing, can create new combustion powered things if they wanted to. But anything outside of the package, such as in main, if I try to say combustion powered thing, old timey train equals new combustion powered thing, what's going to happen? Well, it's going to get real confused, because if you look at the 5 fixes available, create class combustion powered thing. We already created a class combustion powered thing. We can create an interface combustion powered thing. We haven't gotten interfaces yet. We'll get there very soon. And then we have, create enum combustion powered thing. We haven't talked about enums yet either. We'll get there. But basically, we've made it so that if you're importing things from this, like, you want to basically just expose the code that you want to expose, and then leave all the other stuff, the logic behind, so that you don't accidentally, create something. Like, there is no combustion powered thing. There are cars, there are airplanes, there are trucks, but no one says, check out my new combustion powered thing. That would be weird. I suppose someone could say that, but the general idea is to show, or like expose the things that you want someone to use, and then leave everything else kind of hidden away. So now, final bit before we we have time. We have tons of time, and if we don't finish, that's fine too. Final bit. We want. And this is another way to think of, you don't want to write, like, let's say I want to take a trip. So I could say public static void take trip. And I want to pass in, what I'm taking a trip with, and say okay, cool, I'm going to take a trip with a car, like some car. It's a system.out.println. Wow, we're taking a trip with some car dot, and then well, can't see anything. Nothing is exposed. Some car. Let's look at car. That's right. We go up. No, combustion powered thing. These are also protected. And then finally, if we go into vehicle, these are also protected. None of these say public. So what do we want to do? Right now, you know what? I just want to write, I want to create a toString method. What does that do? That converts literally everything to a string. And let's do this with, we should type this out. It's good to type stuff out, but it's also good to know the tools that are in your tool belt. So if you right click the class that you're in and go to source, thank you, Darius, source, then scroll over and then see generate toString. So it should be the fourth or fifth one down in this little section. Generate toString, you click it. I'm gonna just click everything, generate. What is this? That's bonkers. And let me also just clear this guy. Finally, oh, nope. Clear my drawings. So what do we got? We have a thing called toString. It returns a public string and override. I'm just gonna get rid of that for now. Don't wanna, yeah, it's fine. This bit right here, this is called the decorator. And all this does, when you say @override, that means that there's a method in the class that you're inheriting from, and it has the same exact name. So you just want to like kind of replace it or override it. The same thing works like this, but override makes 100% absolutely sure that you're inheriting from a class, from a method that exists in some inherited class. We never created a toString, which is why I deleted it, but I feel like I should tell y'all now, we never created a toString, but what is the case is that every Java object, so the way that we're going, we have vehicle, combustion, powered thing, and then car. We didn't create a toString in any of these at all. However, this is getting into the weeds a little bit, but every single Java class, if you don't extend anything at all, you should know that by default, you're actually extending a kind of secret behind the scenes. You're extending a thing called object. And that has a toString method. So when you automatically generate something that says toString, it's going to be like, oh, override. The code works just as fine without override, but the override decorator is very common. You'll see it. The plan wasn't to show that this week, but such is life. Here we are. Okay, now, so let's look at this car. And this is kind of nice. Car. Radio channel equals radio channel. AC temp equals AC temp. Wheel count equals wheel count. Power source, power source. Get class. This, what is that? That's another thing. Let's remove these. Get class is another object level method. Hash code is another object level method. And then it says toString, it's calling super.toString. Super, if you remember, always refers to, I literally just deleted this. Super refers, so here's car, to the next class up. And the toString method that this guy is referring to, because we didn't actually ever declare one, that's referring to a toString from object. But that's, if you take away anything, just take away that you can, from this bit right here, you'll see override. If you don't fully comprehend it, that's fine. And super just refers to the class immediately that you're inheriting from. So it's referring to combustion powered thing. If you see super, it's talking about this guy. So now we've got this toString, and for the sake of time, because I love talking, I'm gonna right click again in Bicycle, do source, generate toString, do inherited fields and inherited methods. Cool. we get the same thing. You're probably wondering like, okay, what's the point of all of this? Well, you will see right now. So we've got, wow, we're taking a trip in some car dot to string. Great. Semicolon. Always remember your semicolons. Then say public static void take trip. Then say bicycle bike. And because I'm feeling lazy, I'm going to copy paste this entire string, taking a trip with bike dot to string. And you could, well, you could. Let's do this. Let's say take trip, and I'm going to pass in Honda Accord. Then I'm going to write take trip Surly. So, oops, what did I do? Why are you? Take trip car to bicycle. Take. Oh, dang it! Ah, thank you. Spelling is so necessary. Oh boy. There we go. So, and what we did, and then also, I just glossed right over this reminder from like 4 weeks ago, 3 weeks ago. Time flies too quickly. We have 2 of these functions with the exact same name, but different parameters. That is function overloading. But you can do this because the runtime Java knows it's like, oh, hey, you're passing a bike into take trip. You must mean this guy. And it's like, yeah, of course. So we run this code. Wow, we're taking a trip with car, and then radio channel 88.1, AC temp 62, wheel count 4, and then with bicycle, wheel count 2, power source, burritos, and pizza. And there we go. We're printing out all this extra stuff, but yeah. Anyway, fun story. We just did double the work we had to. Like entirely double the work we had to, because both car and bicycle are, like, they are vehicles. So we could, write a function for car, we could write a function for bicycle, and for every other vehicle, we could write a function for those. But I think that laziness is key to efficiency there. So why write like 1,000 functions when you can write a single one? Let's comment these out and make another function called, you guessed it, take trip. Take trip, and then we'll do some vehicle.string. So what do we want to pass in right here? Because cars are definitely not bikes. And cars are not trucks, bikes aren't trucks, bikes aren't planes, planes aren't cars. However, all of these are vehicles. And this is one of the things that I think it's going to take maybe not the longest. This took me forever to grasp, but it's good to like draw it out. That's why I always like to draw these things, unnecessarily large diagrams, vehicle, then combustion thing. And there's the car, plane, truck. Then there's the bike. And I could draw squares around each of those, but that's too much time. It's already quarter till. All right, so then we could do all of that, but why write code for each individual one of these things when you could just write code that says, you know what? Anything that's a vehicle at all, do this. And that's a great question. Why wouldn't you do that? Because you should. So So we're gonna say, okay, I'm gonna pass in a vehicle. Some vehicle, doesn't really matter what it is. Oops, don't delete your parentheses. And of course it's gonna complain and say like, hey dude, like you're not importing that. So you click import vehicles. And then of course, because I wrote some vehicle instead of vehicle. So now we have some vehicle.toString. So if I press play, check it out. We have condensed our code. Also, whoop, yeah, we'll leave that. But ultimately speaking, this now, any vehicle whatsoever, we can add vehicles to it and we don't have to add more code. Like I could add like a scooter or one of those weird like hoverboard things or literally anything. And so long as those classes inherit from vehicle, they can use these predefined methods without any extra code. And that's extremely powerful. So when you're building stuff with like code for your robot, pronunciation's hard, you can then just inherit from things and not have to write additional code, which is bonkers. This is stellar. So that took about extra 10 minutes more than I wanted to, but so now exercise time. Everyone get your computers ready. Start, we are going to create a new, completely new class that inherits from other classes. It's not going to be cars because cars and trucks and vehicles are cool. But what we're going to do instead is talk about biology. Not a ton. We are not taxonomists, but all does anyone remember in your biology class kingdom, phylum, order, class, genus, species? Or kingdom, phylum, class, order, family, genus, species? You're not going to do all those. That's too much time, way too much time. But I want you to create a class just called living thing. Then from there, there's going to be plants, and then animal. Then your animal, you should have one bird, or well, bird, create a bird class and a tiger class. Those are the only animals out there. Then for your plant class, create as many plants as you want, but really just for the sake of time, because there's like 10 minutes. For plant, create a class called Cactus, or I guess you could really make your plant class anything. But so let's plan this out. Come on. So what do birds have? They have wings. They have legs. They have feathers, beaks, and that's it. What do tigers have? Tigers have claws. They have fur, teeth. They don't really have beaks, they have teeth. And then, they also have legs. Forgot that one. They also have a tail, a pretty cool tail. They have lots of other things. What sound do they make? They roar. What sound do birds make? They chirp. All right, now for plants, or for I'm at cactus. What do cactuses do? We've got prickly sticker things, and that's it. So what do all three of these things do? Well, all three of them have to eat, they have to drink water. So what does a cactus eat? They eat sunlight. It drinks water. We'll leave water out because it's what do tigers eat? Well, they're carnivores, so they eat meat. I know I'm being extremely reductive here because life, every animal does everything, but you know, for the sake of time. What do birds eat? Birds eat birdseed. They don't eat the sun. Then what do all living things have? Well, they're all made up of cells. They're all, you know, eukaryotes. You weren't expecting a biology lesson. They're all, yeah, all these are eukaryotes. So how would you turn this into this? You have 7 minutes. No, this was the goal was to have this exercise, but let's start it now. And if you have any questions, any thoughts, I mean, we are here. And then whatever you don't finish will be your homework for next week. It's a lot. Inheritance is a pretty wild concept, but pretty cool. And next week, we'll talk about interfaces, which are even cooler part or cooler thing that we can show off. Also, there are tons of interfaces in robotics, so or in the robotics libraries. That's the fun part. It's all fun. And while y'all are thinking about that, I'm gonna redraw all of this, in fact. So got bird, tiger, and cactus, these little things for that. Let's make one for animal, for plant, and then one for living thing. So let's start with, I think, you know, we can see that all three of these have, you know, cell types, you know, say you can actually how do they teach in what do they teach in biology class these days? So there are eukaryotes and prokaryotes. This top layer, let me get this out of here, is called living things. So we can ultimately make eukaryotes and prokaryotes subclasses, which would be kind of cool. Don't have time for that. The living thing, they're all eukaryotic. All living things have to consume food in some manner. So say food source, make that a string. So, okay, gosh. So we can say like, all right, cool. There we go. Did that, got that. Know what they eat. Cool. Super cool. Now, for plants, let's boil this down a little bit more. So I guess let's start with birds and tigers, because that's what we have when we have time for those. And you can figure, I think you can figure plant out. So birds and tigers. This falls under animal. Birds and tigers both, they both seem to have legs. So just do leg count. It's an integer. Suppose you could make it a double if you wanted, but integers are just, it's easier that way. They have legs. Say they both seem to make noise. Birds chirp, tigers roar. Instead of just having a chirp and a roar, what can we do? We can say, noise string. Then what else can we say? We could say I think beaks and teeth could do that. We could say face type if we wanted. Tigers have teeth, birds have beaks. I don't like that. Let's leave that for the lowest level. Whoop. Sorry. Oh my gosh, my phone is blowing up, making lots of loud vibrating noise. Okay, so then finally, we have noise, leg count. There, we'll leave it at that. So then sound, and then legs. I meant to write 4 legs there. So then finally, let's look at the rest of this. So like clearly, let's do, whoops, text. Bird, for bird. Brid, tiger. We'll do bird. Birds will have like, let's do wing shape. There are different wing shapes out there. And then feather color. And beak shape. Because there are some birds out there like condors with the crazy hooked beaks, and there are other birds like what's the one that like has, it's like a really tiny beak for crushing seeds. There are, a million options. So tiger, finally, we're gonna say claw. We do claw sharpness if we wanted to. We didn't really need to keep claws on there. We'll do fur. I don't think you can see me. I don't know if you can see me typing on. Yeah, fur or stripe pattern. Tooth count. Does that tiger need to floss? And then tail size. Some tigers, like I forget what it was. I think it's one of the Siberian tigers, has really it's a gargantuan tail for balance. It's pretty cool. And then here's plant, cactus. I will leave those to you. So next week, in fact, take a screenshot of this. Next week, we will start with going over this. So if you want to stay and ask questions about how to set this up, please do. Or Thursday at 4 p.m. we have office hours. Come do that too. But and also today's code will be posted in Slack as always. But does anyone have any questions? You need help getting this set up, or are you like already done with it already? You're like, I already got that. 6:01. Class is technically over. It's office hour time. I'm gonna take this silence as a heck yeah. Need all the help. We're just gonna hang out in silence for a bit. Or either, well, I'm just gonna keep talking until someone asks a question. Or until everyone leaves. Either or.
How do you set up a Boolean?
Ooh, great question. Let's get out of here. Ooh, F. Well, that's fine. That's not blocking too much code. So like assuming we had like our airplane for a Boolean type, you just so depending on if you've worked in other languages, some languages they'll say bool. If you've seen that, like you're like, why is this not working? You really just want to write Boolean, like the full word, because that's how Java works. Then Boolean something, and Booleans are always true or false. With I mean, there's no other possibility. It's a 1 or a 0, and that's it. So. And then for eukaryotic being Boolean, like that's only there. All of these are eukaryotic. Like animals and plants are under like the eukaryote domain. But if you wanted to make a cool third class, where's the drawing thing? There it is. Well, this is going to be a bad looking square because could make a cool like bacteria if you're feeling really adventurous. And bacteria are not eukaryotic, they're prokaryotes. And then there's all sorts of crazy stuff. Highly recommend everyone take a microbiology course. It's wild. 11 out of 10. I went to school for biology. The first time around. Any other questions? All right, well, I mean, don't want to hold you all. I think we're good to go. We'll see you next week. And yeah, thanks for coming. And I look forward to seeing everyone's implementations next week. So yeah, see you.